Hello everyone, thank you for taking the time to review this final project presentation. My name is David Reynolds and this is the final project map presentation for the Geographic Information Systems course at Johns Hopkins University. The topic covered in my final project is an analysis of the tree canopy loss within my hometown of Charlotte, North Carolina. And the purpose of this analysis was to see, was there any correlation between higher rates of poverty within census tracts using the 2011-2015 projections in comparison with a University of Vermont study that compared the canopy of the city and the changes to the canopy between 2012 and 2018. So on slide 3, this is the study area. Charlotte is the largest city by population in North Carolina. Consistently has been a fast-growing city since the 1990s. The 2020 U.S. Census put the population at roughly 875,000 in comparison with right under 400,000 from 1990. So the growth in population has really come at a cost of the city's tree canopy. And the study area includes the city limits defined in 2018. My first source came from the Topologically Integrated Geographic Encoding and Referencing Database, also known as TIGER, using 2011 to 2015 projections. And this data was collected and maintained by the Charlotte-Mecklenburg Planning Department. And as you can see, it encompasses the entire county of Mecklenburg. And it shows the population poverty rates between 0 and 60%. The census data contained 233 polygons that were aligned to the individual census tracts for Mecklenburg County and included a specific field for the population poverty rate. The second and largest data source that was used for this analysis on slide 6 was a layer that shows the either gain, loss, or no change of the tree canopy within the city of Charlotte that was created by the University of Vermont Spatial Analysis Lab. And it was quite extensive of what they did, but they ended up using LiDAR-derived surface models, multispectral imagery, and thematic GIS inputs to create a very extensive data set. This data set contained over 830,000 polygons with shape areas, object IDs, and code to denote either gain, loss, or no change to the canopy area. So the analysis methods started with building the geodatabase and adding the shape files from the census and the canopy data within ArcGIS Pro version 2.9.3. On slide 9, you can see lots of failed attempts of various tools that I was trying to run within ArcGIS Pro, different spatial joins and trying to add spatial indices, trying to perform certain intersect functions on the data set that I had, just wasn't necessarily yielding the results that I was expecting. On slide 10, you'll see that ultimately there was some type of syntax error within the loss features from the canopy polygons. So I was able to create a layer with symbology to show only the gains and loss polygons and use the geoprocessing tool, the spatial join, to be able to link the roughly 370,000 polygons that were either gain or losses, since I wasn't necessarily interested in the no change features within the data, to see the intersections with individual census tract IDs. So once the spatial join was done, I needed to understand the concentration of the gains and losses within each census tract. But the census tract information was also county-wide, so I needed to perform a pairwise clip and found a layer of the city limits of Charlotte in 2018 on the ArcGIS portal that was uploaded from a former Clemson University user from several years ago. So after performing that clip, I was only left with the census tract information within the boundaries of the city limits. On slide 12, once my clipping and joins were complete, I took a look at my data to see what cleanup there might need to be post-join, so there weren't any lingering items on my map. The Vermont study did include some areas that were not within the city limits, so I filtered out attributes where there were 0 join values and removed those from the map because they were fairly negligible. I then ran another geoprocessing tool called Summarize Within that gave me statistics for the percentage of gain and loss values within each census polygon of the tree canopy polygons. So since I was only focused on 2 attributes, either gain or losses for canopy, I checked the add minority and majority attributes and the add group percentages, which gave me statistics on the values of gains and losses within each tract and which attribute was the majority. So on slide 13, I was able to select the tracts that were majority class was equal to gain, and found out that there were only 4 of those tracts where over 200 tracts, only 4 of them had net gains of tree canopy within 2012 to 2018. So I ended up removing those from the study because I wanted to focus on just the net loss. So I ended up calculating a value and added a new field where I subtracted the majority class percent from the minority class percent, since all of the remaining majority classes were losses, to calculate a net loss value. And then I used that resulting value to create a new layer called Net Tree Canopy Loss Percentage, and added symbology to show 4 classes of loss between 0 and 38% of the tree canopy within those census tracts. So slide 14, I then used the Select by Attributes feature to focus on census tracts where the population poverty rates were greater than 20%. I created a new layer to add symbology and made sure the selections would not drown out the canopy data. I also increased the transparency of the net tree canopy loss percentage enough to see the underlying road and neighborhood label features. So I tried to include the crosshatch and the grid format to indicate higher rates of poverty within that particular census tract. So here on slide 15, you'll see a clipping of my final map that was created, showing the sources of the information. The legend details show the specific census poverty tracts that go from 20 to 40 and then from 41 to 60%. And then also showing just the net tree canopy loss percentages using 4 graduated colors. There was only one census tract out to the far east that had that 13.1 to 38% loss. And I actually know that area well. It's near where I grew up, and there is a hospital development going in there, so it would make sense that there has been a large canopy loss in that area. My original assumption about higher poverty percentages within these census tracts also being associated with higher rates of tree canopy loss were not found within the data, but I also have to remember that some of these areas that are already suffering from higher rates of poverty also have less tree canopy area to begin with. So the areas that are already in orange, sort of to the south, and the wedge, so to speak, this is a more affluent area of the city, and they already have a higher percentage of tree canopy to lose. So this sort of makes sense that although we see these areas in orange that aren't suffering from high rates of poverty, they did suffer from higher canopy losses overall, but they had more to begin with. It also shows areas to the outskirts, to the southwest, to the northeast, and to the southeast on the outskirts of the city limits that had higher percentages of losses, which also correlates with just continued suburban development in those areas to the outskirts of the city. So as I take some of these results into account, it's going to help me be better prepared to engage with community organizations like Trees Charlotte to get involved in planting within some of these areas and understanding the impact. You'll find a PDF file of the final map in slide 16. These were the three sources of my information. The descriptions and the credits from the census information and the tree canopy information come directly from the metadata from the layer files within ArcGIS. And then just giving credit to Providence I Do, who had posted the city limits of Charlotte layer file on ArcGIS Online. Thank you for taking the time to review this presentation. I appreciate your time and feedback in advance. I'm really excited to see what others have done in the class just to enhance my own learning. Feel free to reach out, send any messages. I look forward to seeing your comments on the board. And thanks again for your time.